Good evening, students. Welcome back to my channel, Physics PART2. Today, we'll learn the position of the center of mass for the continuous body system. That is, the position of center of mass for continuous body. Continuous body. The position of the center of mass along the x-axis xcom should be equals to integration x dm. dm is the small part mass by the total mass of the body, and ycom is equals to integration y dm by m, and that for the zcom is equals to integration z dm by m. Those are the formulas should be used in the case of the continuous to find the center of mass for the continuous body system. Now we move to a numerical. Start the numerical. Let us consider two axes x o x dashed and y o y dashed. A rod has been kept on the x-axis. Its initial point is at o comma o, that is the origin, and its length, if its length is capital L, then the final point is L comma o. Now to find the center of mass for that rod, if we consider it as a continuous body system, then the formula should be xcom, that is the center of mass, that is equals to integration x dm by integration of dm. Now here, to find the dm, let us consider that the total mass of the rod is capital M. Let us consider the total mass of the rod is capital M. Now let's take a strip whose length is dx. If M is the mass and capital L is the length, then the mass per unit length is lambda. That is the linear mass density. Write it. Linear mass density. Linear mass density. Now to find the mass of the dx portion, that is small portion of the rod. What is the mass of the small portion dx, that is the dm? Let us consider that is dm is equals to multiply the linear mass density, that's the mass per unit length, with dx, that is lambda into dx, that is equals to m by L into dx. Now putting this in that equation, what we will have is equals to integration x m by L into dx, and the limit of the integration should be from 0 to L. L is the maximum length, so 0 to L, and in the denominator, integration of dm means the total mass of the rod, that is capital M. Now in the upper part and lower part we have the mass M. Mass should be cancelled out, that is 1 by L into integration 0 to L x dx. Okay, now move to the next line. That is equals to 1 by L, that is x square by 2 is the integration of x, that is 0 to L, that is equals to 1 by L into L square by 2, that is equals to L by 2. So the position of the center of mass for the rod is L by 2, which is the solution of that numerical. Now let's move to the another numerical. The numerical is a rod of length capital L is placed along the x-axis between x equals to 0 and x equals to L. The numerical resembles to the former one, and the linear mass density, here is the difference, the linear mass density rho equals to A plus Bx, where A and B are the constant and x is the variable. Now find the position of the center of mass. Now we use the same formula for that numerical to write XCOM, that is the center of mass. XCOM is equals to integration x dm by integration of dm. First we have to find the dm, that's the mass of the small part of the rod. So here we can write dm equals to linear mass density, that is rho, linear mass density, into dx. Okay, now what is rho? Rho is A plus Bx. Rho is A plus Bx into dx. Now putting that in that equation, what we have, that is equal to integration x A plus Bx dx by integration A plus Bx dx. And what is the limit? Is the limit starting from the 0, that is the origin, to the maximum length L, the 0 to L. Now you can integrate it and find the position of the center of mass of the rod. Now we are moving to the two-dimensional body system. If we consider a lamina, what will be its center of what will be the position of the center of mass for that? Let's write the formula for that. RCOM, that is the position of the center of mass. And for the two-dimensional body, we should consider the area. Now write it A1 R1 vector, A1 into R1 vector, area of that portion, and the position vector R1. Now plus A2 R2 vector plus dot AN RN vector. Now dividing by the total area, that is A1 plus A2 plus dot AN. Now for the three separate axes, what will be the position of the center of mass? Thus the XCOM is equals to A1 x1 plus A2 x2 plus dot AN xn, that is divided by A1 plus A2 plus dot AN. Now YCOM is equals to A1 y1 plus A2 y2 plus dot AN yn by A1 plus A2 plus dot AN. Now for the ZCOM is equals to A1 z1 plus A2 z2 plus dot AN zn by A1 plus A2 plus dot AN. Those are the formulas for the laminars. Now move to the another type of the problem of when, let us consider a rigid body, that is the rigid body. Area of the rigid body is A1 and some mass has been scooping out. The area is A2. what is the center of mass for that cases? What is the center of mass for that cases? We can solve it so easily. The same position of the center of mass, the position of the center of mass RCUM, we can write A1 R1, and the superior part must be subtracted, that is the A2 R2, radius of the scooping out, by A1 minus A2. On the basis of that formula, we are moving to solve a problem. We are going to find the center of mass of the lamina shown in the figure. What is the speciality of that lamina? Here, total is in the solid form, but some part of the lamina has been scooped out. Now let us consider the total area of that solid lamina is A1, and scooping out part is A2. And what is the formula to solve that kind of the problem is RCOM is equals to A1 R1 minus A2 R2 by A1 minus A2. Now what is A1? A1 is the area of the total lamina. That is A1, we can write A1 is equals to pi A square. Pi A square. Now for the A2, area should be, that is A, it is also A, it is 0, 0, 0, 0 is a center, 0, 0. Now here, if it is A and it is the center, that is A by 2. Now we can write pi into A by 2 whole square, that is the area. Now the position of the A1 is 0, 0, and that of the for that case, that is A by 2. Now writing it, A1 is pi A square into 0 minus A2 is pi into A by 2 whole square into R2 is A by 2 by the A2 minus, that is A1 is pi A square and A2 is pi into A by 2 whole square. Now that part is 0, and we have minus, pi should be cancelled out, A cube by 8, and here A square minus A square by 4, that is the 3 A square by 4, that is equals to minus A cube by 8 into 4 by 3 A square. Now here A2, that is equals to minus A by 6, which is the position, minus A by 6 comma 0 is the position of the center of mass for that kind of the problems. That is enough for the day, and goodbye for the day. Stay tuned, and we will come with the new concepts, new knowledge, and new era of the age. For that, till now, stay tuned. Please share, subscribe, and comment.